Hi, everyone. I'm excited to be here today to talk about SEA's work at Hunga Tonga Hunga Ha'apai, or HTHH, Earth's newest persistent landmass in the Kingdom of Tonga, deemed Mars on Earth. I had the great privilege of visiting HTHH last fall in October of 2019. HTHH is a new volcanic landmass formed in 2015 in an explosive volcanic eruption. Today I'll discuss a collaborative mission to better understand the biological and geologic evolution of land formation on Earth and possibly other planets through the lens of HTHH. I'm looking forward to being transported back, and I hope to transport all of you too. Very first off, I'd like to say that SEA's work in education and scientific research on HTHH is part of a unique and exciting interdisciplinary collaboration. The key players are Jim Garvin and Dan Slayback at NASA's Goddard Space Flight Center, their collaborator Vicky Farini at the Lamont Doherty Earth Observatory, the Kingdom of Tonga, and SEA. This collaboration sprung up very organically in 2018, thanks to my colleagues Kim Reed, Jay Amster, Rachel Scudder, and Jeff Westcott through their work with SEA's SPICE program, Sustainability in Polynesian Island Cultures and Ecosystems. The team was initially interested in the safety and the possibility of sailing by HTHH in Tonga, then 3 years old. They reached out to researchers working on the science of HTHH, including doctors Vicky Farini and Jim Garvin of LDEO and NASA, respectively. A new collaboration was born through these initial conversations. The SEA sailing school vessel, SSV Robert C. Seamans, offered direct access to HTHH and an opportunity to involve students in the process of research and discovery there. In 2018, a team of SEA students, crew, and NASA scientist Dan Slayback visited HTHH for the first time in a pathfinding mission to literally chart the waters and test the possibility of access. I was chief scientist for SEA's SPICE program last fall, 2019. My colleagues Emily Height, Chris Nolan, and Elliot Rappaport were part of a return to HTHH in 2019 that allowed for a 5-day dedicated mission to better understand the island and again to involve students in the process. For the most part today, I'll be discussing the 2019 mission that I was a part of, but I need to recognize all of my colleagues and friends at SEA and NASA who made this possible. This collaboration was interdisciplinary and in partnership with the Kingdom of Tonga, who grants SEA and NASA scientific permission to visit HTHH and shares in the data collected. We've also had the great fortune of having 2 Tongan scientific observers join on both 2018 and 2019 HTHH missions, Mafoa Penisoni and Pen Vailea. They are our supervisors when we are on the island. Our work at HTHH is in full partnership with the Kingdom of Tonga, and I need to recognize the generosity of the Geological Service of Tonga and the Ministry of Land, Survey, and Natural Resources and the Ministry of the Environment for providing scientific permits. It's important to us that this partnership is recognized. Another acknowledgement goes out to Patrick Smallhorn West, a coral researcher studying the coral growth and recovery on the island. Patrick allowed us to borrow his ROV for our 2019 mission, and we'd love to have him as a collaborator on future visits to HTHH. I'll also acknowledge Nick Dragone, a former SEA assistant scientist and now PhD candidate at CU Boulder. Nick is using high-throughput genetic sequencing on HTHH sediment samples to better understand microbial colonizers on this new landmass. I'll be speaking about some exciting land-based studies today, but want to say that I'm not a geologist. I consider myself a biological oceanographer, a molecular ecologist, and an educator, and I've been humbled and delighted to work with such a passionate group of students and scientists on this project. As an oceanographer and one of several SEA chief scientists, I've been honored to help organize and facilitate the research and education that we've been conducting on HTHH. This work would not be possible without the participation, work, and engagement of SEA students and our amazing SEA crew of assistant scientists and professional sailors, especially those from SPICE cruises in 2018 and 2019. They made this work possible. Today, I'll speak mostly about the nature of our collaboration and the mission to HTHH that I was part of in 2019. None of this work or this expedition would be possible without the expertise and passion of those involved in this interdisciplinary and collaborative work. I won't be sharing lots of data today because it's in the process of being analyzed, but I will be sharing a glimpse into this island with you and describing the nature of our work there and what we were able to accomplish. Hunga Tonga Hunga Ha'apai in the Kingdom of Tonga formed in early 2015 during an explosive volcanic eruption that took place over the course of about a month. And it connected the two islands of Hunga Tonga to the northeast and Hunga Ha'apai to the southwest. In this photo, you can see the two pre-existing islands. Next, you can see here a photo of the explosive volcanic eruption, and this was provided as an announcement through the government of Tonga. Finally, you'll see the evolution of a new central landmass connecting the two pre-existing islands, Hunga Tonga and Hunga Ha'apai, and this connecting that landmass is known as a tombolo. This image was produced by collaborators at NASA. The island was expected to wash away in weeks to months, but has persisted much longer than expected. It's been around for 5 years now and is predicted to stick around for 30 years or more. HTHH is one of the few newly formed volcanic islands to persist for several years during the current era of satellite-based remote sensing. There are other islands on Earth like it, Surtsey in Iceland and Capellanios in the Azores, but these islands were formed before we had satellite remote sensing capabilities. HTHH then offers a rare and unparalleled opportunity to examine in real time and on human scales the dynamics that allow new landscapes to evolve and persist here on Earth and on other planets such as Mars. This is the motivation for the interest of the United States National Aeronautics and Space Administration, or NASA, and our collaborators, Jim, Dan, and Vicky. So what's in a name? Hunga Tonga Hunga Ha'apai is the temporary name of this connected landmass. Ultimately, it's up to the King of Tonga to name the new landmass. In our discussions with partners and friends in Tonga, we heard some great new naming suggestions, but the King has not yet given the landmass an official name. He's probably waiting to see how long the island will stick around. But for now, in this presentation, we'll refer to it as HTHH. Here's a picture of the island from the top of the crater rim. So moving from a satellite perspective to stepping foot on the island and up to the crater rim. So why is a collaboration with SEA part of the picture? First, SEA travels to remote locations across the world's oceans. You can see from this image some current and previous SEA cruise tracks. We have an almost time series-like process of scientific data collection and observations based on these repeat cruise tracks. There's a huge potential to maximize these repeat cruise tracks and involve students in ongoing, relevant, and cutting-edge research. As a small sailing vessel, the Robert C. Seamans is able to get close to islands such as HTHH with less impact. Another key element is the involvement of students in this real and exciting process of scientific research. Integrating students into this type of scientific collaboration fulfills some important mission goals of inspiring environmental leaders, ocean scientists, and engaged citizens. Here's a glimpse at SEA's SPICE cruise track, which has been running for over 5 years. The red circle indicates the location of HTHH. So the cruise track involves departing from American Samoa, going through Tonga and making several port stops there, and then going into Suva, Fiji, and concluding in Auckland, New Zealand. And as you can see, our cruise track goes right past Hunga Tonga Hunga Ha'apai. And on the right here, you can see a map of the bathymetry of the region. So our cruise track runs right past the Kermadec and Tongan trenches, archipelagos, and back arc basin. And this is one of the most geologically active places on our planet, where the Pacific plate subducts beneath the Indo-Australian plate, leading to a line of underwater active volcanoes, islands, and surface volcanoes, and one of the deepest ocean trenches in the world. So why Mars? On the left, you'll see a satellite image of HTHH, and on the right, you can see small conical volcanoes on the Martian landscape that have been modeled to be flooded with water. The two look pretty similar, right? It's now thought that the planet Mars was once covered with water, and the landscape on Mars that we can see today evolved in the presence of standing bodies of water far in the past. So observing HTHH and tracking its change over time will provide insight into land formation and evolution on Earth, but it can also be a proxy for understanding the Martian landscape and perhaps land formation on other planets as well. These ideas are compelling to Jim Garvin, chief scientist at NASA's Goddard Space Flight Center, and has also really inspired our work there too. So thanks, Jim. So here's Jim, a picture of Jim Garvin. Here's our ship, the SSV Robert C. Seamans, and it's anchored off of HTHH in 2019 with the backdrop of a really beautiful sunset. We were anchored off the north end of the island. The science and activities that I described throughout this presentation can also be attributed to the involvement of these C semester SPICE students and our amazing crew of mates, assistant scientists, engineers, and stewards. All right, so at this time, I'd like to show some drone footage from our 2019 mission, just to give you a sense of place. Some of SEA's best drone pilots happen to be our captains, Jay Amster and Chris Nolan. The drone footage I'm about to play is thanks to Chris's expert piloting in 2019. After we go through some of this drone footage, I'll dive into some of the details of the surveys and research that were conducted on HTHH in 2019. And I'll show some photos of the process. So in October of 2019, for 5 days, students, faculty, and professional crew shuttled back and forth from ship to island using small boat operations. The coordination of a team of 41 people involved daily morning planning meetings and nightly debriefs, mission teams, and lots of logistics. We had teams distributed throughout the island for 8 to 10 hours a day throughout the 5 days, accomplishing tasks like drone surveys, marine debris pickup, geological surveys, bird and vegetation surveys, GPS marker installments, coral surveys, installing a rain gauge, and more. And this mission required good coordination, communication, and teamwork. And I will say that the learning and educational opportunity of having students involved in this type of mission and project can't be overlooked. The island is primordial and harsh. The new landmass is comprised of tiny pebbles that get stuck in your shoes and become hot in the sun. There's no shelter or drinkable water on the island. It's uninhabited. We also had a day of rain and winds, which made small boat operations challenging during our time there. Every day we had folks on the ship holding down the fort and maintaining important shipboard operations, while other teams were assigned to mission activities. In the ship's lab, throughout the ship and on the island, there was a sense of excitement. HTHH is a really inspiring place, and it truly feels like another planet. Our hope is to make it back there and to continue this very collaborative work, again, with SEA, Kingdom of Tonga, and with NASA. So what you're seeing here is the crater lake of the volcano. We're zooming into 2 inflatable pack rafts that we deployed in the lake with a small side-scan sonar device that allowed us to map the bathymetry of the lake and also some of the waters in the south side of the island that were uncharted. This was a pretty adventurous activity and mission element, and I'll talk to you more about this in a moment. But yeah, you can see the 2 pack rafts being towed across the lake. Okay, I will show you some more drone footage at the end of the talk as well. So here's a photo of the Robert C. Seamans anchored off of HTHH. And the photo below shows some of the excitement on board as we pulled into HTHH in 2019. We anchored off the more sheltered north end of the island. Getting to and from the island every day involved small boat shuttling of about 20 to 30 people back and forth, and some challenging small boat landings. To do this, we relied on our expert and amazing crew of professional sailors and assistant scientists with SEA. To conduct scientific work and coordinate 41 people in a mission on an uninhabited remote landmass requires planning and logistics, but also flexibility. Our mission plans were initially compiled during a dedicated planning workshop session at SEA in Woods Hole. The session involved SEA students in the process and was led by NASA Goddard Chief Scientist Jim Garvin, NASA scientist Dan Slayback, who also joined SEA in sailing to HTHH during 2018 and 2019. The mission planning session also involved SEA faculty, including Elliot Rappaport, Emily Height, and myself. Our plans include GPS-based drone footage, vegetation and bird surveys, crater lake mapping, nearshore side-scan sonar mapping to get a 3D image of the bathymetry on the south side of the lake, of the island, sediment and rock analyses and collection, microbiome studies, coral studies, and marine debris removal. But we also had the stated educational goals of involving students in the process of scientific research, mission planning, execution, and discovery. Here's a map that was created in 2016 by the RV Falkor, which is the Schmidt Ocean Institute research vessel, with our NASA and LEO collaborators. The team was able to map the seafloor around HTHH up to the 30-meter isobaths. But the Robert C. Seamans can get closer. And we plan to land people on the islands and map the near shore with a small boat and side-scan sonar instrument. So the white space in this map was literally uncharted water before our 2018 and 2019 missions. I love this map, which was produced by NASA's Dan Slayback, who joined us on the voyage. This map illustrates the diverse array of surveys completed in 2019 in October. The white polygon outlined regions with the diagonal shading highlight the 5 regions that were covered in drone surveys. The 3 red triangles symbolize locations of geodetic markers that say Kingdom of Tonga on them and are controlled with GPS location. The 10 blue squares indicate where some geolocation drone targets were placed. The yellow lines within the crater lake and along the south shore of HTHH represent the bathymetry surveys that were carried out by small boat and pack raft operations with that small side-scan sonar attached, giving us a 3D map of the ocean and the lake bottom. And actually that side-scan sonar device is called a Lowrance, which is actually a fish finder that has the added application of being able to map the bottom in 3D, which is pretty cool. Okay, so now I would like to discuss some of the specifics of these mission operations. The first op I would like to discuss is our work in the crater lake. Initially, our goal in the crater lake was to use the pair of pack rafts that you saw and a small side-scan sonar instrument to 3D map the bottom structure of the lake. Basically, we wanted to map the vent structure of the volcano. You can see the 2 pack rafts and view screen of the side-scan instrument in this photo. But of course, before entering the lake, we tested the pH, the chemistry, the temperature, even the phytoplankton diversity of the lake to make sure the water was safe to operate in. It appears that the crater lake water experiences high connectivity with the adjacent ocean. The lake water is salty with the pH and phytoplankton community of seawater. And there doesn't appear to be any flesh-eating bacteria. We were able to achieve our mapping goals in the lake, but we also found more, including evidence for ongoing geothermal activity on the island. This was discovered really serendipitously by a student, Grace Callahan, who fell into the lake mud upon exiting the pack raft. She noticed that her feet were warmer than the water above. And this was a really interesting finding. And we went back the next day to investigate further. Using our hands and testing the temperature of the mud along the rim of the crater lake, we found several geothermal hot muds, mostly on the southwest side of the lake. If you've got your audio on, I'll ask that you mute yourself. Glad to have you. Awesome. Okay, so we're finding all of this hot mud around the rim of the crater lake. We also used a thermal imaging camera to confirm this finding. So this is a thermal imaging camera, and here you can see that the sediment is much hotter than the water around it. This was a really major finding of our 2019 mission, and it was all driven by a serendipitous student discovery. Geothermal heat may be baking the island in place, leading to the process known as pelagonization, and could be responsible for the island's persistence over time. And this is something that is worth exploring further. The discovery of geothermal hotspots in the crater lake demonstrates the power of human observation. One could make the argument for the value of human-driven exploration of remote environments, such as Mars or the deep ocean. So are humans better than robots or drones? Big question of our time. Perhaps they are for now. So I will let Grace tell you her story.
My name is Grace Callahan. I'm a biological sciences major at Wellesley College. Right now, we've just left HTHH and we're motor sailing our way to Tonga Tapu. and it's a beautiful day. So I was part of the Crater Lake team. So I did some science scan sonar transects of the lake and some plankton tows, just trying to get a sense of what the lake is like physically and also biologically. And I was also part of the geosurvey team. So I did some hikes to the crater rim and identified some cool rocks that we found and logged those. So it was my first day on the island. And we were finishing up the side scan sonar transects of the crater lake, and I was in the boat, and the sides of the crater lake drop off very fast. So I jumped out of the boat, not realizing that I was immediately up to my chest in water. And the bottom of the lake is sort of a layer of mud and then a layer of looser gravel. So I sunk right through, and I was trying to hold the boat steady, and my legs were about 1.5 feet under the sediment, and then my feet felt hot. And I said, oh, that's weird because I'm 1.5 feet down in gravel. And the lake itself is not hot. It's around the same temperature as the surrounding ocean. So I pulled one of my feet out and tested the gravel on top, and it was cold, and the gravel underneath was hot. And I thought, this is super weird. I reported it to Kerry, our chief scientist, and she was pretty excited about it. And so I got excited about it again. So I went back the second day, the second afternoon, but I kept going around and sticking my feet into the gravel. Probably for about 10 or 15 minutes I did that until I found another hotspot, which was super exciting. And once we found that one, we just kept finding them, and everyone got in the lake and was feeling around, and we found hotter and hotter ones. So this has definitely, having the exposure, especially to Dan Slayback and NASA, has really reinforced my interest in geosciences.
Okay, thank you, Grace. So now another story, and this is the story of the coral reefs around HTHH, and it's the story of resilience and recovery so far. Volcanic eruptions represent an enormous disturbance event for coral reefs. We know that coral ecosystems are being bombarded by many human impacts, like ocean warming, acidification, nutrient pollution, and sedimentation, also overfishing. If you attended Heather's talk on Tuesday, you would have learned a little bit more about that. But a volcano, this is a natural geologic impact and a very destructive one. So around the island, huge coral heads were impacted directly by the explosive volcanic event or covered with ash and died and were smothered. But in the years since the eruption, the coral seems to be recovering. And I'll direct you to the work of Patrick Smallhorn West, who's been tracking coral recovery and health in Tonga. So please see the paper citation below. And I think Patrick's on this call too. So if you have questions for him, we can ask them at the end. So Patrick, who is based in Tonga at the time, allowed us to borrow his ROV for our 2019 HTHH mission. We conducted ROV surveys and snorkel surveys and sent the footage back to Patrick. It's clear that there's massive regrowth with abundant and diverse juvenile coral growing on these large ash-covered coral heads. We also observed a bustling coral fish community and numerous reef sharks. The resilience of these HTHH coral populations is remarkable, and it's been attributed to their remoteness and freedom from many human-derived stressors, like nutrient or chemical pollution, sedimentation, and overfishing. Of course, warming and acidification are still impacts that that affect these corals. The HTHH coral communities give us a glimmer of hope, showing that corals can recover from dramatic disturbance when they're not dealing with so many overlapping human stressors at once. Our geologic survey on HTHH was largely exploratory. We took photos of rock types and layering of sediment and ash, and we cataloged various rock types and their GPS locations. We sent some rock samples back to our friends at NASA, who will be analyzing them further. We also took some sediment samples and sent them to our collaborator, Nick Dragon, at CU Boulder. So Nick has been running some high throughput genetic sequencing to explore microbial communities across the island. He's also a former SEA assistant scientist. His findings will shed light on some of the pathways of microbial colonization on Earth and in volcanic environments. Our geo-surveys took us all over the island, including up some canyons of the cone. So here's an image of the entrance to those canyons. We've got Jill and Jenny and Bess for a sense of scale. Here are some photos of the diverse rock types observed in our survey of the island, and some sediment types. We also observed some evidence of other underwater volcanic activity in the region in the form of these long rows of pumice that were washed ashore in the rack line. These could have been from a large pumice raft, which was observed to be the size of Manhattan, encountered off the coast of Tonga and Fiji just weeks before we set sail, or another underwater volcanic event producing pumice or floating rock. This pumice and the volcano itself really goes to demonstrate how geologically active this region is. And our friends in Tonga on the call really know everything about that. Here's a photo of Olivia, who's operating a drone on the left, and a geodetic marker, which was installed on the island on the right, with the Kingdom of Tonga noted on the GPS monument. So these monuments are GPS controlled and will give us a sense of some change over time. In this photo, Penn, our Tongan scientific observer, and Dan Slayback lay a GPS-based drone target. These drone targets were distributed throughout the island, allowing Dan to base the gridded drone flights in precise geolocation. Over 56 drone flights offer unprecedented, high-resolution imagery of the island, which will help to track changes and evolution in the landmass over time through digital elevation models, or DEMs. Here's an example of some of the high-resolution topographic details that can be obtained using these drone data. This is a photo of the ash canyons that are leading from the cone to the crater lake. And Dan shared some of these high-resolution drone stills with me just yesterday. He's again using these drone data to create elevation models and essentially to track fine-scale changes in this landmass over time. But I think that these high-resolution drone stills are in themselves really works of art. The Earth is one incredible place. They're just really beautiful. Thanks, Dan, for sharing these with me. We performed vegetation surveys of the island, identifying diverse plants that are spreading and colonizing the volcanic cone from the pre-existing islands of Hunga Tonga and Hunga Ha'apai. So when the volcanic event happened, the plants from the pre-existing islands weren't completely wiped out. Penn, our Tongan observer, helped to identify some traditional medicinal plants that were colonizing the new landmass, and even identify some young guava and coconut trees. These vegetation surveys are important in characterizing early stage ecological colonization processes. Vegetation can also lead to landmass stability, so it's really important to track the spread of vegetation when predicting and better understanding the longevity of this landmass. So here's an example of some of the vegetation surveys, and I think this is Renee and Sally performing one. Wildlife is abundant on HTHH. We observed nesting birds, including sooty terns and petrels. There were 12 bird species that were identified and 5 that were unidentified. It also appears that nesting sites have changed since the 2018 visit. We also identified a sea crate, which is a sea snake that's native to Tonga. And we observed countless humpback mothers and calves feeding off the coast, coral fish and reef sharks, and even a juvenile whale shark that popped up during a small boat bathymetry mapping survey on the south end of the island. It's clear that HTHH and the water surrounding it harbors and supports rich biodiversity and habitat. So here's an example of the sea snake in its natural habitat, filmed underwater. Here are some photos of the birds that were observed and counted on the island. It might not surprise you that HTHH is also impacted by humans and has not escaped marine pollution despite being Earth's newest landmass. Students and crew spent 5 days collecting debris across the island. We found marine fishing gear, shoes, and innumerable pieces of plastic. The trash was collected and disposed of in the next port stop in Nuku'alofa in Tonga. All in all, we collected over 600 cubic feet of garbage. You can see the black trash bags on the left alongside the dock. And those black bags are debris that were collected on HTHH. On the right, you'll see trash from 41 crew that accumulated over 2 weeks aboard the Robert C. Seamans. And I'll also note that when SEA visited HTHH in 2018, they also conducted a big effort for marine debris removal. So what we saw in 2019 was the accumulation of just 1 year. So we have a problem, and this is a global problem of marine pollution. So this brings me to HTHH and its cultural significance. Culture and human nature relationships are really important aspects of developing social and ecological sustainability. SEA students in our Sustainability Polynesian Island Cultures and Ecosystems program learn directly from our partners and our friends in Polynesia. And we've had the great honor of exchanging ideas and dialogue with friends from environmental, government, and conservation groups in Tonga and Fiji. And we're extremely grateful to them for exchanging their knowledge with us. These include folks from the Ministry of Land, Survey, and Natural Resources in Tonga, researchers from the University of South Pacific, and students from there as well, the South Pacific Community Group, Penn's family, who treated us to an incredibly special umu during our time in Tonga, students from in Fiji from the International School of Suva. We were able to kind of exchange the story with them as well. Again, we've had amazing scientific observers throughout the years from Tonga. We've hosted shipboard dinner discussions and visitors, and we're also delighted to share our data with the Kingdom of Tonga as a scientific partnership. So we hope to continue this work that really merges scientific insight with education in a unique and fruitful international and interdisciplinary exchange. So this work is to be continued. Our 2019 mission to HTHH exceeded expectations, but there's still more work to be done. This project represents a rich and unique interdisciplinary collaboration. It's led to scientific discoveries that are still emerging. It also supports deep student involvement and educational opportunities in leadership, science, collaboration, and teamwork. The data we've collected is in the process of being analyzed, so stay tuned for more. But there's also an impetus to revisit HTHH and learn more and continue to monitor change. There's always more opportunity as well for cultural exchange and deeper partnership with our friends in Tonga. I'll also say that we just had a paper that was accepted and is in press at JVCGR, and this is a pathfinding paper to really highlight the unique interdisciplinary collaboration and the work that was conducted just this fall on HTHH. So yeah, take a look out for that. Okay, so what I'm going to do is just kind of leave us with some of this drone footage here. And while this is playing, I would love to gather some questions from our audience. And I think the best way to do this would be for you all to enter your questions in the group chat, and I'll try to answer them. We also have Patrick on, who's agreed to maybe answer some questions about the coral. Just looking to see who else is on here. We also have Mafoa, who is the 2018 Tongan observer on the call. So hey, Mafoa, if you have anything to add, please, we'd love to have you contribute. What is an umu? An umu is a amazing, delicious barbecue, traditional barbecue. Do any of our Tongan friends want to describe what a umu is for our question? It's one of the most delicious meals I've ever had in my life. So, how big is HTHH? It's about a mile long. The new landmass is about a mile long. The two pre-existing islands are are really steep, so it's pretty hard to access. There are some big cliffs. Mafoa was the first person to step onto HTHH on behalf of SEA in 2018. So, yeah. I think it's my understanding that Mafoa provided a kind of a blessing before others stepped onto the island, which yeah. The depth of the crater lake, asks Michelle. So the data from the side scan sonar is still being analyzed, but I recall it being not deeper than 15 meters. So it's pretty shallow. Is there a chance of another eruption and the island growing bigger? I think there's always a chance of another eruption in this region. So yes, that's a possibility. Other questions? We don't have, there are no seismometers on the island right now. Are there private visitors allowed on the island, and are local people spending any time on it? I think there are some, there have been some local visits, but I think in large part it's uninhabited. How far is the nearest populated island? So Nuku'alofa is only like 30 nautical miles away. So it's pretty close by. Are the collaborators in Tonga continuing surveys when SEA is not there? I know that Taniela, who is on the call, I think if he's still on, he actually visited HTHH as it was erupting. I don't know if they, have you guys been back recently? Mafoa or Taniela or Celia?
Hi, Kerry, and hello to everyone else, and hello, Malo Lele from the Kingdom of Tonga. Yeah, I recently visited the island during the passing of our late Prime Minister. It was through with a person of interest. He wanted to visit on its own, so I asked him to, it's best I accompany him on my personal interest in having another look at the island. So we've seen what you're showing on the screen there. We took some drone imagery as well. We also swam into the crater as well. So it's interesting to see that you actually did the same thing. We were hesitant at first, knowing the pH level might not be normal. But yeah, we took the risk of walking and feeling the bottom of the crater, which is just like as you described, somewhat warmer. But yeah, our interest in the island is continues with NASA's continued monitoring using satellite imagery, and of course, you installing the benchmark there, the geodetic mark. And we are trying to establish it as a conservation island. So just to protect it. And some private sectors are now applying for permits to access the island for tourism purposes. So we have not, since the eruption of White Island in New Zealand, for public safety, we have not granted any permits. But of course, these are attractive to the tourism sector. We'll try and work out a way of how we can safely allow them to access the island. Another note I took by visiting there is that people go there anyways. Maybe fishermen or just people who pass by. So it's likely there's no control over the access to the island. But in terms of scientific study, for now, we have growing numbers of graduates in earth science and environmental science in the ministry, and in the Ministry of Environment as well. So we're thankful to the SEA for the continuing program, and we are supporting it for the purpose of having access to new information and the scientific methodology that you're applying, so that we inspire into scientific investigation in general. We'll heavily rely on you guys and piggyback on your research into the island, and we'll continue collaborate and see where we go from there. Thank you, Kerry.
Thank you so much. I really appreciate you providing that input, Daniela. And we might be in touch really soon about the rain gauge that's on HTHH if you're able to get back there and download the data. Okay. I think that might be really, really interesting information over the course of the years. So.
Yeah, and speaking on that note on visiting, we are only short on financing of chartering any boats. There are boats around. They're probably close to around 3,000 per anga, which is 1,500 US, for a day's visit. We don't mind going there. We just need 1,500 US dollars. Thank you for each visit. Yeah.
Well, I think that's what makes kind of this collaboration really, really exciting. To be able to share in the knowledge and the science.
Yes. Thank you.
Thank you. We've got a lot of other questions. So Patrick also input that some people do kind of swing by the islands, locals on the weekends, fishermen. What makes the lake water so green? So there's a lot of sediment in the lake, but it appears to be really connected with the seawater. It's not fresh water. Let's see, what future research is in the works for HTHH? So we would love to get back there this fall, again with the same kind of collaborative initiative. Again, COVID-19 and plans for travel are, we still have a lot of contingency plans there, and we're considering our fall trips really carefully. What would potentially cause the island to even last longer than 30 or more years? Okay, so Dave, that's a great question. So one hypothesis is that this process of pelagonization is happening, and Jim Garvin is definitely the expert on this, but the idea is that the rock and the ash is baking in place, and that's why finding the geothermal activity in the Crater Lake is really interesting, because it suggests that there's some residual heat there that can help to stabilize the island. And also vegetation is also another way that land masses like this can stabilize. So has NASA considered subsurface sampling of sediments to see if microbial communities have occupied niches deeper down? This is hypothesized as a possibility on Mars. That's a really great question. Right now, the sediment samples that we've collected and are being analyzed by our collaborator at CU Boulder, Nick Dragone. These are surface sediment samples, but taking sediment samples deeper down would be really interesting. Already, the sediment samples are showing very interesting microbial communities, especially on the new landmass. So stay tuned for that, and that's work coming out of the efforts of Nick Dragone. All right, I'm wondering if I don't see any more questions. I don't know if I've missed any. Still happy to answer more questions. Would Patrick be able to comment on how the coral growth is returning? Patrick, are you still on the call?
Hey there. Yep.
Hey, thanks.
Yeah. So we've been out to the island twice over the last few years, and we haven't been out since you were there last year, unfortunately. So we haven't seen how it's actually returning since then. But what was cool to find is that along the kind of northeastern edge of the island, the reefs there were actually completely unaffected by the eruption. So it looks like the mountain or the pre-existing island had actually blocked any damage to the reefs. So there's a completely one of the healthiest kind of reef ecosystems that we've seen in all of Tonga, actually, along that northeastern edge. And what looks like is happening is that that's actually recolonizing the reef, the kind of coral communities and the reef fish communities along the rest of the island. So it's been cool seeing kind of diversity and coral cover metrics like that actually drop off as you get further away from that protected zone.
Thanks so much, Patrick. I recommend that people check out Patrick's new paper. It's really awesome, and it was such a privilege to be able to snorkel around the reefs of HTHH and use that ROV. So, is anyone studying the microbial community in the Crater Lake? Sam, great question. Part of the collaboration with Nick Dragone at CU Boulder is to understand the microbial community across the whole island, including microbe communities associated with the Crater Lake itself. So that's a great question. Oh, hey, Nick. Okay, so Nick, if you're on the call, if you want to elaborate, that would be great.
Yeah, Kerry, I definitely can. I would say, just to elaborate on the first question, based on what we see, every single sample we took has a distinct microbial community. I would say that based on what we're seeing, it's not too different than other types of volcanically created sediment. So there's no reason to expect that there wouldn't be microorganisms lower down on the island in deeper sediments. Not necessarily in the way that NASA predicts on Mars, but just in the fact that there are a lot of microbial communities deeper down. With regard to the second question, yes, there are a lot of interesting microorganisms in the Crater Lake. Again, we're still looking at preliminary data, but we are seeing a lot of organisms that are often found in deep sea hydrothermal vents, which is an interesting result in itself.
Thanks so much, Nick. Yeah, so a lot of the data that was collected this fall, as you imagine, is still being analyzed, and I think a lot of interesting findings will come out of this research. And Celia, yeah, you can see the Patrick's paper citation there. Aerial view showing the bathymetry seemed to show what looks like a submerged caldera adjacent to the existing new landmass. Is this the case? Yes, this is the case. So HTHH, here I'll just show, is part of a larger caldera. So as you can see in this survey that was done by the Falcor, HTHH is kind of on the edge of a larger caldera that is far older than HTHH itself. Is there existing data on the microbial community of the two surrounding islands? No, I don't believe there is. Good question, Charla. Yes, so HTHH is a new tombolo that was formed in a volcanic eruption that took place on the rim of a previously existing caldera. Volcanoes on top of volcanoes. Also, for those of you interested in looking at the literature, keep your eyes peeled for this new paper exploring the human nature dimensions of Hunga Tonga Hunga Ha'apai, Earth's newest landmass, which is being published in the Journal of Volcanology and Geothermal Research. I think it's going to be published like next week. The turnaround time between going there in the fall and getting a paper out was really fast. So that was really exciting. All righty. So It's about 3 o'clock. If I don't see any more questions, I just want to thank all of you for joining us today, especially collaborators, everyone from Tonga who was able to join us very early in the morning. Also, please tell Penny that we say hello. Also, oh yes, thanks, Mark. Okay, I'm going to flip through these slides really quickly. I also want to plug the next lectures that are coming up. Let's see. We have next Thursday, Professor Craig Marin's presentation, From Sugar to Storm Surge. Oh my gosh, I'm sorry, I'm failing here. Here we go. Okay. Whew. All right, so you can see the next 2 lectures that are coming up with SEA's lecture series. Don't miss it. Great, and thank you everyone. I'm just looking at the chats. You can always email me if you have questions that come up after the fact, and it's been a pleasure. So thank you.
Thank you, Professor Whittaker.
Thank you.
Thank you, Professor.
Thank you.
Signing up from Tonga.
Maybe we'll see you again there soon.
Yeah, we should. Thank you, Mafua and Celia.
Yeah, Maginella.
You.
Thank you, Mafoa. Thank you, Celia. Thanks, everyone. Okay, I'm going to end the meeting. I hope everyone stays safe, has a great day. Oh, and also these beautiful flowers behind me are from a local farm. So just kind of a plug to support your local farmer during this challenging time. And it's springtime here in Maine, so. Malo. Stay safe, everyone. Thank you.
Where in Maine are you, Kerry?
I am in Lincolnville, Maine.
Lincolnville, right across from Islesboro.
Yes, yes, indeed.
Yes,
Midway.
yes.
Yep.
Hoping to visit there again this summer. We sail around. See my background? That's
Yep.
That's a Vinyl Haven, Ferry Creek.
Beautiful.
Yeah. Okay, thanks again.
Thank you.